Welcome back to my YouTube channel. This is your boy Providence. Today I'm back with another code tutorial. So today I have SIerpinski triangle in 3D. So the first part I did it in Grasshopper itself. If you haven't watched, check in description below for Grasshopper version. And this time I'm going to do it by C# inside the Grasshopper itself. So let's start. Serpinski triangle is this kind of triangle which keeps subdividing itself. So what we are going to do, we are going to make this 3D. So let's start in a Grasshopper with C#. We disable everything. We start from scratch. But before we start from scratch, I could like to restart from. No need to blow previous script. So let's disable everything and put on the side. So first of all, let's start by polygon. And we put and ghost here, and I don't want to see the plane. Extract the plane, then we put the number of sides. It's at the moment I put 3 sides and 2000 size of the polygon. Okay, I hope you can see it. And find area, then move our point in Z direction. With the same length as we have the side, to have this pyramid. Extrude on point. The base will be this one. So we have a pyramid. Let's down into mesh first. Build up to mesh. This one. So reason why to turn into mesh, it is easy to work with. So we have the mesh. So type C#, and here we put mesh, and make sure the type will be mesh. Then number of iterations, which will be integer. So we put mesh and iteration, let's put 3 at least. Okay. First task, as here we done it. We are going to remove a duplicate because we have a mesh vertex. We want to scale the polygon for on each vertex on top, on all sides. So we are looking for point, so we want to remove duplicate. So first of all, let's check how many points we have. For naked points, we have 12 points. So we need to remove them. The first code we are going to make is code for moving duplicates. So okay, open it and make sure you refer to a namespace called the link. Before anything we will need it. I'll show you how when we need it. Let's start. First of all, we are going to remove duplicate. As you see, naked point we have 12, so we want to have 4 point to scale our pyramid around. So let's create the method for removing duplicate. The method will return point or vertex called point f, list of point f, and the method will be remove duplicate. We get the list of points or list of vertex. 3df pt, then we cross our method. So before anything, let's create our unique list of point and unique pt, which will initialize first, and this one is the one we are going to return unique point. Okay, did here. So we're going to make each loop to iterate each point. So let's do it for each. For each point, we are going to just get the point, of course, point f. We're going to call it p1. Then we're going to iterate pts, this one. Okay, this is our first loop. So we are going to have a boolean, which is going to help us to keep checking if it is duplicate. Is it duplicate? Here the mistake of spelling duplicate. So we should change here. Is it duplicate? We have to initialize with false. Let's imagine at the first there is no duplicate. Okay, we make a nested loop, which we are going to have point 3f, which we're going to call it p2, and they are going to iterate into our unique point. Then we'll make loop. So after iterating, we have to check if first point pt1 and p2, their distance, if it is equal to 0, that is a duplicate. So if pt distance p1 distance to pts to p2 equals to 0, we have a duplicate, and its duplicate will be true. So this duplicate will be true. Then in this case, we have to break the loop. We have to get out the loop immediately. So after checking the duplicate, we need to take pt1 to add it in our unique list. So out of the nested loop we created. So add pt1 here, then we cross it. So here the method is done. Let's check. We have an issue on 7.2. It's not 3df, it is 3f 7.2. Yes, that solves the problem. So let's check if it is working or not. Remove duplicate. This is the method we need. and the vertex we get it from the mesh. This mesh we are getting as input vertex, and we have to make sure that it is in list, so we need to convert into the list. Sometimes it might be in arrays, so then we cross. So we're still having 12 point duplicate probably here. Before we add, we need to make a loop to check if we have difference with duplicate. If there is no duplicate, we need to have a point. We need to have 1 point. So that's what was missing. So then it is working. We have 4 points. So these 4 points. Okay. Let's put result B. Okay. So next method we are going to scale. We are going to make SIerpinski triangles in 3D. So what we are going to do, we are going to scale this pyramid around of the vertex. So we will get the list. We return the list of meshes, and let's call it fractal. And then we will get, of course, mesh. We get number of iteration. And then we have to return the list of mesh. List of mesh, we call it the result mesh, cause initialized. Then close it. Then here we return our result mesh. This result mesh. Result mesh. Okay. That's it. Then the next point, it is first of all to remove the duplicates. So first of all, we're going to get a list of vertex inside our loop. Let's call it vertex. So the vertex will be getting this method remove duplicate. We make it like this, the same exactly like this. So this will be our vertex. So the first loop we are going to make, of course, we are going to first of all to make the list of mesh, which is going to help us to store a temporary meshes. Let's this list call it meshes, because they're going to help us to keep receiving new meshes. And then before anything, we should add in these meshes, you should add the first mesh we are getting, which are this one. The first loop we are going to make is, of course, the number of iteration we have. We call it iteration to 0. Then iteration must be greater than it. So then iteration plus, and we make this loop. So the second loop, of course, it is a loop which going to pass through to all meshes we are getting from here. we use for each. This probabilities mesh we're looking for. Base mesh, call it base mesh in meshes. Then we cross the loop. Meshes. Okay. So the nested loop, you want to take this mesh and scale around the vertex. This vertex we are getting. Okay. Make it for each loop, and we're going to point 3f, and let's call it pt, chaos in vertex. Close it, then make this loop nested loop. Okay, so let's first of all create a new mesh. We call it scaled mesh, or let's call it new mesh. Okay, we initialize with empty mesh, close it, and this new mesh. In order to not scale our original mesh, we need to pass the mesh we are getting from meshes as a duplicate. So the way to do it is to add as a part, to add it as an appendix. So in this case, we not get the duplicates. So we add this base mesh. In this case, what it helps us is not to scale the original mesh, because if we keep scaling this one, we keep scaling on the original mesh, but here we are passing as copy. So close it, and then let's create transform for scale. Call it scale. Okay, transform. Scale. Then we need pt. This the vertex, the current vertex pt. Then we need scale factor 0.5. Then we cross it. Then we need to scale this point, this mesh here. So add no scale. This transform, not scale. And then we put a property we have created for transform. Close. So here we are good so far. So before anything, let's create a temporary add a temporary list of meshes which is going to help us to pass new meshes. So let's call it current mesh. So this current mesh, we need to add this new scaled mesh, the mesh we are scaled. This one, new mesh. Okay, the one we are making scale on it. So let's see, we add it in our list. So after adding in our current mesh, this current mesh which are inside loop, our first iteration loop, we are going to to add it in our desert mesh. So let's add it and make sure it is add range, because it is a list. We're going to add current meshes, add S current meshes, so that are predefined clear. So close it. Then here our meshes, we go to our current mesh. So this mesh we are creating here for holding our mesh, we are getting new. So after we finish all first iteration, for example, we went through to these meshes or mesh holder through it, because the first mesh we added is the one we are getting from our loop. So imagine that the first iteration we have a first mesh, this one. Then after scaling around our four vertex, we get 4 meshes in our current holder meshes list. So that's what we put in list as first iteration. Imagine we have second iteration. That iteration will be having 4 meshes. So we make for each loop in our meshes, because a current mesh holder will equal these meshes which are holding our meshes. So for second iteration we have new mesh inside our meshes. So for second iteration we have 4 meshes. So 4 meshes will make each loop to go in each meshes and scale around each vertex. So let's check if we have mistakes so far. We have tons of mistake. The name of vertex does not exist. Let's check the problem. Or probably here we haven't initialized vertex. So the second mistake is that mesh, the current mesh does not exist in the context. Let's check. The mistake saying that the current meshes does not exist in the content. So I think here we have changed names, but current meshes not current mesh as single. So let's change in everywhere, here, also here, and also here. So result is not exist in current context. Let's check the why is it like that. So result that mesh is this one. So we have to add it from here. Okay. Also here. So it seems there is no mistake. Let's go ahead and make result B. Result B, we need to have a name of method, fractal. In fractal we need mesh and number of iteration, cross. Okay. That's it. We can increase the number of iteration. and be careful with the number of iterations that tend to be heavy for many iterations. So let's check the result. We have 583 in 3 iteration. Means that there is small mistake we're doing. Let's check. This is the method fracture. We make result mesh as the wrist which going to hold all result of mesh. We make vertex and make sure the duplicate is removed, and we make a mesh holder for our temporary mesh. So after that we make for loop for iteration how many recursive we want. Secondly, we create the current mesh which going to pick and fill into result mesh. Also this one is current mesh or temporary meshes holder list. So we make another for loop which going to take log from the mesh we have currently. It is one mesh because we are taking the mesh we are getting from the user from input as a first mesh. That means it's in the loop it is one single mesh, and we find the vertex we are getting here, which will be for vertex, and we scale around it. So after that we get a scaled mesh which are 4 meshes which will be added in current meshes. So after getting those meshes in the result, probably in result mesh we have to add the range of meshes, but we need to exit in this this follow for iteration so that we not have duplicates. So from out of iterations in current we don't have to get outside from for uh, for iterations. What we need to go out is this for each loop, this nested loop, so that our current mesh will be equal mesh holder or container, this one. So this current mesh for mesh we're getting, it send it back to meshes will be equal to meshes. So the next iteration will be have for mesh, next one will have 16 up to next. So I think now it is correct. Now you can see we have 83, which we can go beyond with 7 iteration, for example, and then that's it. Let's disable and then enjoy the first script. So thank you so much, see you next time. I hope you subscribe and you like this video, share to your friend. Thank you so much. This is a result, simple mirror your result. Thank you so much. Bye bye, see you, bye, ciao.